Hello Math 140 students, we are going to pick up on page 7, section 4.2, solving systems of linear equations by substitution. So by substitution, what that really means is that you're going to plug one equation into the other. So here, for example number 1, we have this top equation, y is equal to 4x minus 1. And we have this bottom equation that I'm going to highlight in green, this 6x minus 5y is equal to negative 2. What we can do is we can substitute the first equation into the second equation. And the reason I picked this equation to substitute is that the y is already isolated. So because it's already isolated, I'm going to go ahead and write down my second equation. 6x minus 5y is equal to a negative 2. So now I know that I'm going to be plugging in for my y variable. So I have a 6x minus 5. And now that variable y, it's really that 4x minus 1. And it's equal to that negative 2. So all I did was grab that y equation and plug it. So now I have to distribute. So I'll have a 6x. So this negative 5 is going to get multiplied inside to give me a negative 20x. And a negative 5 times a negative 1 is a positive 5 equals to a negative 2. So now I have 6 minus 20, which is a negative 14x. Plus 5 is equal to a negative 2. From there, I'm going to subtract 5 from both sides so that a negative 14x is equal to, and negative 2 minus 5 is going to be a negative 7. So if I divide both sides by negative 14, I'm going to get my answer. So 7 divided by 14 is going to give me a 1/2. So now I know that my x variable is 1/2. So I still need to find my y variable. So now find y value. So I'm going to take that first equation, which was y is equal to 4x minus 1. And remember, I had found out that x is equal to a 1/2. So I'm going to plug that into my equation. So I'm going to plug that into here. So that I would have a y is equal to 4x minus 1. And I'm plugging in there a 1/2. So if y is equal to 4 times a 1/2, that would give me 2 minus 1 would give me a 1. So now I have an x value and a y value. So my solution is going to be the ordered pair, a 1/2, comma 1 for the x and the y. That is how I do the substitution method. With number 2, we can see that the x is already isolated in that first equation. And so I'm going to go ahead and plug it into my second equation. So my second equation, I have 2x minus 3y is equal to 2. And since x is isolated, I know that's what I'm plugging in here. So I have a 2, and now that x value that I'm plugging in is a 3y minus 2. And I have minus a 3y is equal to 2. So now I'm going to distribute to give me 6y minus 4 minus 3y is equal to 2. So I'm going to rewrite this as 6y minus 3y minus 4 is equal to 2. Just students are less likely to make a mistake if they rearrange it. So that way when I combine the 6y and the 3y, I combine those together to give me a positive 3y. So then from here, I'm going to have to add 4 to both sides. So that 3y is equal to a positive 6. Now I'm going to divide both sides by a positive 3 to give me that y is equal to a positive 2. So now that I have my y value, I'm going to use that to get my x value. So now find x value. So from that first equation, we had x is equal to a 3y minus 2. That's an equals there. And what we had found was that y was equal to 2. So I know that I'm going to plug that into my y variable here. So x is equal to 3, my y value minus 2. So that y variable that I'm plugging in is 2. So I get x is equal to 6 minus 2, which is a 4. So now I know that my solution is an ordered pair where I have my x value and I have my y value. And that x value I found was 4, and the y value that I found was 2. So my answer here is 4, 2. Number 3 is really similar, where I have x being isolated, and I have my bottom equation. So I'm going to go ahead and rewrite that bottom equation. I have a negative 2x plus 4y is equal to 12. So since x is isolated, this is where I'm plugging that equation into. So I have a negative 2, and now that x value becomes a 2y minus 6, since that is the equation that I am substituting in for. So when I distribute, I'll get a negative 4y plus 12 plus 4y is equal to 12. So if I just rearrange this, I have my negative 4y plus 4y plus 12 is equal to 12. So what happens is that negative 4y and that positive 4y, they cancel. So now you have 12 is equal to 12. This is a special case. This special case means that it's true. Always true. 12 is always equal to 12. So what this tells us is that we are going to have an infinite amount of solutions, because we actually have a dependent system. And if you remember from last chapter, a dependent system really just means that two lines are exactly the same, or that they are identical. And so that is going to be my answer. Now for number 4, I have to kind of set it up. I have to isolate one of the variables. And it doesn't matter which equation you choose, but it has to be one of them. I see that this has a coefficient of 2, that has a coefficient of 6, this has a coefficient of 3, but this has a coefficient of a negative 1. So I think this is going to be the easiest one to solve for. So I'm going to go ahead and just rewrite this. So my first equation, I have a 2x minus y is equal to a negative 1. So I'm going to subtract 2x from both sides. So I have a negative y is equal to a negative 2x minus 1. So that means I'm going to divide each one by a negative 1. So that y is equal to a 2x plus 1. So that is going to be my equation number 1, which is perfect, because now I can plug that into my equation number 2. So equation number 2, I have my 6x minus 3y is equal to a positive 3. Since y is isolated, I'm going to plug that equation into my y variable. So I have a 6x minus 3. And now that y, since I'm plugging it in from here, I have a 2x plus 1, and it's equal to 3. So then 6x, now I'm going to distribute that negative 3. So negative 6x minus 3 is equal to a positive 3. So now that I have 6 and negative 6, I know that those are going to cancel to give me a negative 3 is equal to a positive 3. Well, this would be false. Negative $3 is not the same as having $3. That isn't possible. You can't have negative and positive at the same time. That means the values would not be equal. Okay, so you want these values to be equal. So since that is false, we're going to say that this is going to be a no solution. And hopefully you remember that when we had no solution, it really just meant that the two lines were parallel. So they were never going to have a solution. They're never going to meet. They're never going to have a point of intersection. For number 5, we're going to take that framework and apply it to a word problem. The perimeter of a college basketball court is 288 feet. If the length of the court is 40 feet longer than it is wide, what are the dimensions? So first of all, I want to deal with the shape. Here, it's the perimeter of a basketball court. So a basketball court, hopefully, you remember, just kind of looks like a rectangle, right? Like maybe there's a hoop or something. Okay. Not the best draw, but more or less, you know, that's going to be the shape of a basketball court. It's just going to be a rectangle. Maybe I should just draw that a little bit better. Okay, there's my rectangle. And the perimeter, hopefully you remember, would equal to 2 lengths plus 2 W's. So you add all the lengths and the W. So this would be a length, and this would be a W. So this is just generic in general. Whenever you're thinking about the perimeter of a rectangle, this is the shape and the formula that you have. The really nice thing about this is that you have what the perimeter is actually equal to. It's equal to 288. So this is what it's equal to. So 288 is equal to that formula of perimeter. Okay. Now, it also says some other pieces of information that we're going to be using. It also says that the length of the court, so now we're thinking about the length, so we're thinking about this, is 44 feet longer than it is wide. So 40 feet longer than it is wide. So in reference, this is the width. So length is going to be 44 more than the width. So the length is equal to W plus 44. So now I have my equation. I have 288. I have this equal to 2. And remember, this L here, it's rewritten as this W plus 44. And I still have my plus 2W. So this gives me, after I distribute, 2W plus 88 plus 2W. So 288 is equal to, and here I have 2W and 2W. So I'm going to combine that together to give me a 4W plus 88. So then from here, I'm going to subtract 88 from both sides. So now I'm going to have a 200 is equal to my 4W. Well, I can divide both sides by 4 to get the W by itself. So 200 divided by 4 is going to give me 50. So when it's specifically asking me for the dimensions, I know that it's asking me for the length and the width. So for the width, I can say easily that this is 50 feet. The length, well, now that I have the width, I know exactly what that's going to be. Remember that my length was equal to W plus 44. So if I found this value to be 50 for my width, I add that to 44. So 50 plus 44 is going to give me 94. So that tells me that my length is going to be 94 feet. Okay, now let's think about number 6 here. It says Luis currently sells stoves for Appliances Inc. at a salary of $12,000 plus $150 commission for each stove he sells. Electronics company offers him a position with a salary of $24,000 plus a $50 commission for each stove he sells. How many stoves will Luis need to sell the options to be equal? So he wants to know when these equations are going to be equal. You might be thinking, what equations? Well, we have to come up with those equations. So here's the first one. This is your salary plus a $150 commission, and that's for Appliances Inc. So let's call one the Appliances Inc. Remember that we have a linear equation. A linear equation is usually as a y is equal to mx plus b, where b represents your flat rate. I guess in this case you can think of it as your salary. And here your m value is your rate, or your m, or your slope. And in this particular word problem, it's going to be your commission. So I'm going to write my equation for Appliances Inc. as y is equal to that, and that 150 is the commission, so that's my m value. So 150x, and that salary is going to be my 1,200 or 12,000. Okay. Now we want to talk about the electronics company. Again, I want that y is equal to mx plus b. So I have a salary. So whenever I see salary, that's going to be my b value. And when I see that commission, that's going to be my m value. So I have y is equal to a 50x plus 24,000. So the cool thing about this is that these are both equal to y. Since they're both equal to y, then I can set them equal to each other. So I have 150x plus 12,000 is equal to my other equation, which is that 50x plus the 24,000. So what I'm going to do is I'm going to subtract 50x from both sides. So if I have 150 minus 50, that gives me 100. And here I'm also going to subtract that 12,000. So now I have my 24,000 minus my 12,000, which is going to give me 12,000. So I really have that 100x is equal to 12,000. From here, I'm going to divide each side by 100 so that x is equal to 120. So remember, x represents the commission for each stove. So he would have to sell 120 stoves in order for these two companies to pay him the same amount. Okay, and that is the end of section 4.2. If you guys have any questions, please feel free to reach out to either the Math Success Center or tutoring, or me, your tutor, your teacher. Thank you.